In this video, we're going to do some more work with integrals. Now we can always kind of brute force and evaluate an integral, although in some cases we do have a few shortcuts we can take. And one of those is to look to see if the function is an even versus an odd function. So remember, for something to be an even function, it says that f of x is equal to f of negative x. So a positive versus a negative input of the same value will give me the same outcome. It means the graph is symmetric with respect to the y-axis if you were going to graph it. An example would be f of x equals cosine x. An odd function says when I put in a negative value and evaluate the function, I get the negation of the function evaluated at the positive value. So this means the graph is symmetric with respect to the origin. So an example would be f of x equals sine x, or f of x equals x to the third. So when we have an even function, as long as f of x is even, the integral from negative a to a of some f of x function is always going to equal 2 times the integral from 0 to a f of x. And that's because this is an even function. So we have the example, the integral from negative 1 to 1 of x squared plus 1 dx. So first we're going to verify that it's an even function. So we're going to plug in f of x, and we get out x squared plus 1. And we're going to try f of negative x. Well, that would be negative x squared plus 1, which is still x squared plus 1. So this is an even function. So that means over here I can reevaluate this as 2 times the integral from 0 to 1 of x squared plus 1 dx. So now I have 2 times, my integral is 1/3 x to the third plus x, and I'm evaluating that from 0 to 1. So now I have 2 times 1/3 times 1 plus 1 minus 1/3 times 0 to the third plus 0. And so by putting that 0 there, I know that the second half is just going to be 0. So this is 2 times 1/3 plus 1. So this is equal to 2 times 4/3. So this is equal to 8/3. Now if a function is odd, the integral from negative a to a of f of x will always equal 0. So it will make our life a little bit shorter. We won't have quite as much work to do if we recognize that it's odd. So we want to evaluate the integral from negative 2 to 2 of x to the fifth minus 3x dx, but first we have to verify that it's odd. So we need to evaluate f of negative x. So that would be negative x to the fifth minus 3 times negative x. So this would be negative x to the fifth plus 3x. And then we want to check, is that equal to the negation of f of x? Well, f of x is just x to the fifth minus 3x. So this would be negative x to the fifth plus 3x. So this is an odd function. So without having to do any more work, without actually having to find the antiderivatives, I know that this integral is equal to 0. All right, so let's try another. So we have evaluate the integral from negative 3 to 3 of x to the third minus x dx. So we have to see if it's even or odd. So I'm going to start off by finding f of negative x. So that's going to be negative x to the third minus a negative x, which would give me negative x to the third plus x. And then I'm going to say, well, is that equal to the negation of f of x, which would be the negation of x cubed minus x, which equals negative x cubed plus x. So this is an odd function because f of negative x is the same thing as the negation of f of x. So without doing any more work, this integral is equal to 0. All right, let's try one more of those. We have the integral from negative 4 to 4 of negative 9x squared plus 10x dx. Again, we're trying to see if it's even or odd. So I'm going to start by evaluating f of negative x. So that would be negative 9 times negative x squared plus 10 times negative x. So that would be negative 9x squared plus 10x. Or excuse me, minus 10x. I lost my negative. And then I want to find out what's the negation of f of x. So that would be equal to 9x squared minus 10x. So in this case, the graph is neither even nor odd when I look at the whole function. But remember, I'm also allowed to break this up and do negative 4 to 4 of negative 9x squared dx plus the integral from negative 4 to 4 of 10x dx. So now if I use these new functions, f of negative x for my first function would be negative 9 times negative x squared, which would still be negative 9x squared. So this first piece is even. Now my second piece, if I do f of negative x and I plug it into 10x, I'm going to get 10 times negative x, which is negative 10x, and that's equal to the negation of f of x, which would be negative 10x. So the second piece we know is odd. So now when I evaluate, this is 2 times the integral from 0 to 4 of negative 9x squared dx plus 0. So now I have 2 times negative 9. X squared becomes 1/3 x to the third from 0 to 4. So I have 2 times, if I clean that up a little bit more, negative 3 x to the third from 0 to 4. So I have 2 times negative 3 times 4 to the third minus 0. So 2 times negative 3 times 4 to the third is 64. So now I have negative 6 times 64, which is negative 384. Now when we're working with integrals, we can also use our integrals to help us find the average value of a function over a given interval. So f bar, that's our average function, is given by 1 over b minus a times the integral from a to b of f of x dx. So if we want to find the average value of sine x on the integral from 0 to pi, I would say that my f bar, my average, is equal to 1 over pi minus 0 times my integral from 0 to pi sine of x dx. So this is equal to 1 over pi. The integral of sine is negative cosine x evaluated from 0 to pi. So my 1 over pi is staying out front. So I have negative cosine pi minus negative cosine of 0. So now I have 1 over pi times cosine of pi is negative 1, negative times negative is positive. Negative times negative is positive, cosine of 0 is 1. So the average value is 2 over pi. So our average value theorem leads us to the mean value theorem for integrals. Remember, mean is another word for average. So if f is continuous on a closed interval a, b, then there has to exist a point c somewhere between a and b such that f of c is equal to the average value for our function, which is equal to 1 over b minus a, the integral from a to b of f of t dt. So that's saying that there's some value, f of c, that has to equal the average value on that interval. So let's try one. It says find the points at which f of x equals 8 minus 2x equals its average value on the interval 0 to 4. Well, first I need to figure out what is that average value. So that's 1 over 4 minus 0, the integral from 0 to 4 of 8 minus 2x dx. So this is 1/4. My antiderivative here is going to be 8x minus x squared that I evaluate from 0 to 4. So this is 1/4, 8 times 4 minus 4 squared, minus 8 times 0, which is 0, minus 0 squared. So I have 1/4 times 32 minus 16. So this is 1/4 of 16, which equals 4. So f bar, my average value, equals 4. So that's telling me that there's some c value for my function that equals 4. So if I want to find out what that c value is, I know 8 minus 2c has to equal 4. I subtracted 8 from both sides, so I have negative 2c equals negative 4. And I know that c equals 2. So if I plug in 2 for c, I get the function value which is equal to my average value. So the values that this works at is when c equals 2.